Okay, let's have a look at population sampling. Firstly, we're going to look at the terms that we're going to come across in some of the questions that we're going to look here. Key to this is the idea of population, and this is the set of all the members of a particular group. So a population typically is something that we associate with things like a country or a town, but the population of something is just the set of all those members. So if you've got a population at your school, for example, or your sporting club, or whatever it is that's a group of people, that whole group is the population. Now, within that population, there'll be subsets. So for example, at a school, it might be your year level, it might be gender groups, it might be house groups, it could be ages, it could be hair color, any sort of thing where there's, you can group people, and each of those smaller groups is called a subset. And we refer to that as a sample. Next is this idea of survey. Now, I'm sure you're familiar with the idea of survey. It's something that most students have done through their primary school years. It's where you collect information, and typically from this we collect information from a sample. For example, you might go and survey a certain number of students from each year level, or you might just survey one particular year level in order to get their opinions about something. But if you go and ask the same questions to the entire population, so in other words, if you asked the whole school, for example, what their favourite fast food was, then that would be seen as being a census, okay? Certainly here in Australia, we have a census every few years, and the government uses that information for forward planning for its resources. Sample size, so this is the number of the participants. So if we're looking at a sample size for most classrooms, that would be a number like 20 or 22 or 25, because that's the number of students that would be in that classroom. We also then need to look about whether the question and then the answers we're getting are representative or they're biased. So representative responses would be fair. It's where your question has been asked to a spread of people within the population, and you're not getting a result that's unfair or biased. So for example, if you were going to ask whether we should build a new playground at our school, and you went and asked the children that are in grade 1, and those grade 1 students already play on playgrounds all the time and they would love to have another one, then of course they're probably going to come back with a biased view saying, yes, we'd love a new playground. But if you went up to your year 9 students and said, would you like us to build another playground at your school? And these are students that never play on the playground and have no intention of doing it, then they'd probably say no. So it skewers the results. So in order to get a fair representative, you've got to be careful about what your sample size is. Lastly here, measurement errors. So this is where you've done something within the way you've conducted the survey that could potentially affect the result or skewer the result or create an outlier. So for example, measurement errors can sometimes be in the way you ask the question. So you could ask a question where you'd say, wouldn't you agree? And so you're pushing the person to agree with you when you go to ask the question. Other things could be asking a sample group where there's something that's affecting them. It might be school camp that week, so a whole lot of students might be missing. They could have some illness going through the class, so a whole lot of group of students are missing. It could be that 2 classes have been combined together, and maybe those results are going to be skewed. So for example, if you had a grade 5 class that were mixed with a grade 1 class, and you were going to survey how tall students were, the results are going to be skewed differently to other classes that don't have that mixture. And then it might create what we call an outlier. An outlier is a really unusual result. It's one that is incredibly different. So when you graph these results, you normally see all of the grouping in one little spot, and then right to one end, either smaller or larger, you'd find a result all on its own, which we would refer to an outlier. Okay, we've got a couple of graphs here. So imagine we're graphing the results. So these could be test scores, for example. And what we're normally after here is a nice symmetrical result. Now, that doesn't mean when we're talking symmetrical, we're looking for the basic overall shape here. That it's effectively even rise and then even fall away. Now, you will find with these that they won't be exactly the same on each side. Okay, so don't be looking for it to be like millimetre perfect, so to speak. But just for that overall shape, what we call the bell curve is giving us roughly that symmetrical shape. Skewed results means that results are either skewed up or they're skewed down. So for example, if you were looking at the number of students who perhaps got a perfect score on their spelling test. And you might find in your class a lot of kids that are really good at spelling, and you might find the results are skewed up because the spelling words everyone's doing well. Then you might find the teacher goes, oh, well, we're going to have a really, really hard spelling test, and all of a sudden the results are skewed down. In other words, not as many students are getting perfect scores. So skewed results means that there's a higher point geograph compared to the lower point. And it might start lowest and higher, or start higher and end lower, depending. And lastly, we're looking at bimodal. And you'll see with bimodal, we have this sort of symmetrical, but it rises up and then down again, and up and then down again. And typically what this will show you is that there are two groups within the population. It could be to do with gender, it could be to do with age, it could be to do with experience or cultural background. So it splits people into two populations and gives us some results according to that. Right, so we want to find out the average age of drivers in our city, and we're looking at these two choices. So you could ask all of your friends what their age is and gather results from that, or you could randomly ask 1,000 people. So look at which of these is a better option. We're looking to see whether it's a representative answer, and asking your friends would typically not be representative because most people have friends in their own age group. So in other words, in this case, if you're asking about age, then you're going to get answers that are most likely all the same age anyway. So that's not going to give you a spread of information. Whereas asking 1,000 random people, it means that you're not just taking them from one group, you're taking them from most likely multiple groups and then getting an indication whether they're driving or not driving. All right, let's have a look at open versus closed questions. So when we're going to survey someone, we would normally ask them a question. So for example, who is your favourite singer? That on its own is considered an open question because the person answering it can give any answer they like. The difficulty with open questions is you often end up with such a spread of information, it's really hard to classify it in order to actually get some meaningful results from it and conclusions. So one of the things that is often a really good idea is to close your question off. So who is your favourite singer from this group? And then you give a list of choices. You could do the same thing with what is your favourite food, what is your favourite movie, and these closed questions mean that people can only choose from the ones that you've given them, and then that gives you data that you can then tally and then you can make comment on in relationship to that data because the spread is not so wide.